Hi guys, welcome to the Pepcoding. In this video, we are going to solve split array largest sum. So we have given an array which have non-negative integers and an integer m. We need to split them in m parts such that all the m parts are non-empty continuous subarrays. And we need to find the minimized largest sum among these m subarrays. So let's see it by an example. Let's say we have 7, 2, 5, 10 and 8. Now we have m is equal to 2. So we need to split them in two parts. If you want to split them in two parts, there are multiple ways. We can part them like 7 and then 2, 5, 10, 8 in the second subarray. For first subarray the sum is 8. For second subarray the sum is 25. Now we can also part them like 7, 2 and then 5, 10, 8. Now for 7 and 2 the first subarray sum is 9. For second subarray sum 5, 10 and 8 is 23. Now there is the third way. We can split them like this: 7 to 5, then 10 and 8. So for 7 to 5, the value is 14, and then 10 and 8 is 18. There is one more way. The last way is we can split them like this and then 8. This will be 7 to 5 and 10. That means it is 24, and in the second subarray it will be 8. Now we have the m subarrays, and we can see in each subarrays there is no empty subarray. We have all non-empty subarrays which are continuous also: 7, 7, then 7 to, then 7 to 5, then 7 to 10, then 7 to 10. And here we can see 2, 5, 10, 8, 25, 5, 10, 8, 23, and 10, 8, 18, 8, 8. So here we can see in these subarrays, the largest sum is 25 in this subarray. The largest sum in this is 23. The largest sum is 14, 18. In this, the largest sum is 24. Now, here we need to return the minimized largest sum. So the minimized largest sum will be, here we have number of largest sum. For this subarray, the sum is 25. For this subarray, the sum is 23. For this subarray, the largest sum is 18. For this subarray, the largest sum is 24. We need to return the minimum of these. So the minimum is 18. We are returning 18 here. So this is how we are. This is what we have to do. So let's see how will we do this. This is very similar question we have done earlier for allocation of minimum pages for n students. So this is very similar to that. Here we will use binary search, where let's take this example again: 7 to 5, 10 and 8. The low will be the lowest sum. What can be the lowest sum? If we have if we have 5 subarrays, to split them, the smallest sum or the maximum sum will be 10. If we have 5 elements and also 5 subarrays to split, we can split them 7, 2, 5, 10 and 8. And here if we see the maximum, this will be the 10, and there is no other subarrays, we can divide it in, so this will be the answer. So for that, this means the lowest sum will be 10. The highest sum can be, if we need to split them in only one, we need to add these all. If we add these all, the sum will be 32. This will be the answer. So highest sum is 32. Now Let's find a mid. Mid will be, mid is here the expected sum for splitting the arrays. Now this mid will be 10 plus 32, that is 42. 42 divided by 2, that is 21. This is the mid. Here this mid shows that the expected sum of the subarrays which will be lie under this or equal to. Now uh, let's say we have subarray starting from 1. Now we are adding the elements in subarray first. This sum will be first element 7, it is less than 21. We are adding the second element, that is 2, so this is 9. Now we are adding 5, this is 5, we are adding 5. Here the sum is 14. Now again add 10. For the next value we are adding 10. Here we can see it exceed the expected sum. Expected sum was 21 and we have the sum, that is 24. So we need to add this element in the second subarray. So it will increase the subarray count, and now second subarray will start from 10. Okay. Now this is 10. The next element is 8, which is make it 18, and it is also smaller than 21. So we can see if we split them like 7 to 5 and 10 and 8. This is for first subarray, this is for second subarray. We can get an answer which is 21, the expected sum we have. Now we have find answer 21, but is it the right answer? Can we also split them in a way where the answer will be less than 21? So for finding that, we will move our high to mid minus 1. Mid minus 1 is 20. Now we have given a range from 10 to 20. Our sum will be lie if 10 to 20. This means the minimized largest sum will be that value. So now again find the mid. Mid is 15. Now again subarrays start from 1. I am going to add the subarray elements. First I am adding 7. It is smaller than 2. Then adding 2. It is smaller than it is now 9, smaller than 15. Now adding 5. It is 14, smaller than 15. Now adding 10. It is greater than 15. So it exceeds the limit we have from the mid. Now we will increase our subarray and start our sum from 10. Now the second subarray start from 10. It is smaller than 15. Now we are adding 8. Here it makes 18 and 18 is greater than mid. So it exceeds the value. So we need another array, another subarray. So it will increase by 1, 2 to 3. Now here we can see we have the m2. We need to split them in 2 parts, but we are splitting it in 3 parts. So this means the value we have taken for expected sum is smaller, is very small to get the value. So for getting the right value, we will move our load to mid plus 1, that is 15 plus 1, 16. Now again find the mid. Now if we find the mid now, it will be 18. Again subarray is 1. Sum start from first subarray's element 7, then 2, that is 9, then 5, that is 14, still less than 18, then 10. The array is continuous, but here when we are adding 10, it exceeds the limit, which is 24, and we have the limit of 18. So this means 18 is not the this means we need to add this 10 in next subarray. Now we are going to add this 10 in next subarray, and we will increase the count of subarray by 1. Now it will start from 10. 10 is smaller than 18. plus 18, it is more than equal to 18. And here our elements are ended. So this means we have make two subarray whose sum is less than or equal to 18. This means this can be the answer, and which is also smaller than answer. Here answer will be updated by 18. So this will be the minimized largest sum. But now there may be chance of getting smaller value than 18. So now for this we will again move our high to mid minus 1, that is 17. Now again find the mid. Again find the mid. Mid is 16. Now for 16, subarray is equal to 1. Starting from 1, we are adding the elements in first subarray. First we are adding 7. It is more than 16. Then adding 2. It is more than 16. Then adding 5. It is smaller than 16. When we are adding 10, it exceeds the value of mid. So this means we need the next subarray. So we will increase the next subarray value, and then the sum will start from 10. Now 10 is smaller than 16. Now it will add the next element, that is 8. Here we can see it is 18, which exceed the limit. This means we need another value, another subarray, and we have the subarray to use 2, only 2. We need to split this in only 2, and we are splitting it in 3 when we have the expected sum 16. So this means we need to change the expected sum. For changing that, now we will increase the value of low by mid plus 1. This means mid is not the right value, so mid plus 1 can be the right largest sum. So we will increase this. Now again find the mid. Now mid is 17. Subarray is starting from 1, adding 7, then 2, still smaller than 17, then 5, still smaller than 17, then we are adding 10. Here it exceeds. This means we need the second subarray. Now sum will start from 10, then it's more than 17, then we are adding 8. 10 plus 8 is 18, which is greater than mid. This means we need the third subarray for this 8, and we have only 2. So we need to update our low again by mid plus 1. So this will be 18. Here the condition for binary search is low should be less than or equal to high, and low is here greater than the high. So loop will break, and we have the answer 18 as the minimized largest sum among these m subarrays. So what we need is we need to find, is it possible is possible to split the subarrays in exactly m parts. So we need to check this for updating our answer. So let's do the code. First we need the lowest. Now first we need the maximum of the array. Now we need the sum, will be start from 0. Now we will iterate for int I is equal to 0, I is less than array dot size I plus plus size I plus plus. Now for sum will add all the elements of array at I. This will be the maximum expected answer. Now for lowest expected answer will be maximum of maxi comma array at I. Now there is a case if we have m elements and we need to split them in, we have n elements and we need to split them in m elements. If they are same, this means we need to return the maximum value. Let's see. Let's say we have 7, 2, 5, 10 and 8. M is equal to 5. We need to split them in 5 parts. So if we want to split them in 5 parts, this can be 7, 10, 2. The third subarray have some 8. Fourth subarray have some 10. Fifth subarray have some 8. So the maximum value is 10. And there is no any other subarrays possible to compare this 10 with them. So this 10 will be the answer. So we are returning the maximum value from this array. Now we need the low. Low will be start from the maximum value. Then high will be start from sum. Now we will start our binary search. Now we need to find the mid. Mid will be low plus high divided by 2. Now we will check if it's possible to split the array with this range in m parts. If it is true, this means our answer is the mid. And we will check for the smaller value. There can be possibility that the answer will be smaller than the previous one. So high will be moved to mid -1. Else this means we need a greater value than mid. So low will be updated by mid +1. And here we will return the answer. Now what we need is we need to write this is possible function. So let's write this bool is possible. We have the vector int of array. We have the mid and we have the m value. Now we need a sub array starting from 1 and we need a sum which will be start from 0. Now for int I is equal to 0, I is less than array dot size I plus plus, we are iterating to the array. Now we will check. First we will add the sum, add the array at I to the sum. Now we will check if sum is greater than mid. This means we need the second subarray. So we will increase the value of subarray by 1 and sum will start from array at I. Here we have seen when we have 7, 2, 5, 10 and 8 and we were splitting in range 7 plus 2 plus 5 and having range of 17. So this is equal to 14. When we are adding the next value, that is 10, it exceed, which is equal to 28, it exceed the limit. This means we need the second subarray. So we are increasing the value of subarray by 1. And now after this we need to check is the number of subarray is less than or equal to m. If it is, this means we are possible to make our array split in m parts with range mid. So mid will be the answer. So this is the code. Let's run this. Here I have write something wrong. This is array dot size, not length. We have given a vector. Now again I haven't declared the answer. We have to declare the answer. Int ans equal to 0. Initially answer was at 0. Now it is giving a wrong answer. It should give 8 and we are getting 0. Let's see what is the wrong with the code. Here I am adding the maximum. Maximum will be the maximum element from the array, and I am adding that. So let's again run this. So it is giving the exact answer. We are getting 18, as we have already seen the try run here, and the code exactly do this which we have discussed. Let's submit this. So all the test cases are passed. Hope you understand the concept. It was very good question. Please like the video, share the video and subscribe the channel. Thank you.